So welcome to our new video, which is going to be about loops. So why do we need loops? We sometimes need to execute a block of code several number of times. And the loop statements allow us to execute a group of statements multiple times. For example, we have written in here a print function for a shortcut of cout function. For example, we mentioned about string library before. So we pass to the print function a string type variable, and word gets cout printed out from the print function. So for example, if we comment this out and compile this and run it, it prints hello world. So what if we want to do this operation more than one time? For example 6 times. So it prints 6 times hello world, right? But we don't want to write this each line every time. So we can do something like, for example, our first loop is for loop, and there are three conditions in our first for loop. For example, we state in the first part the start of range of our for loop, and in the second part we state the condition. For example, I smaller than 6, because the previous example we printed out of hello world 6 times. So our you can think about it like, think it as a counter of this for loop. For example, it starts from 0 and we set the third condition as I++, which means that when we get into this for loop, our variable or counter starts from 0. Then it gets the end of the for loop after the operations, after our operations. For example, we can print hello world, and after each operation, before getting to the new loop, executing the new loop, this condition gets called. If it's first, this I++ gets executed, like in the first loop we were 0, I was 0, and after getting the first loop, I++ gets called and I becomes 1, and after that we check the condition of if I smaller than 6. If I is not smaller than 6, then we don't get into the further loop. So we break out the loop and do next operations. So let's check this out with this example. For example, this is going to be like 0, 1, 2, 3, 4, 5, and it doesn't get to 6, because if I is equal to 6, it doesn't get into this for loop. So 0 to 5 times, then it's 6 times gets executed and 6 times printed hello world. So you see, hello world. So we can, these integer I, we are declaring an integer variable in the for loop, but this integer I belongs to this scope of this for loop. For example, you can't call you can't call the I in here out of the for loop. Let's check this out, if we can call it or not. See, I was not declared in the scope. So I only belongs to for loops for loop scope. Therefore, or another type to implement the for loop can be like this. We can leave this part empty and declare the I here, for example, and it starts from 0 again and it gets incremented. Or we can do this, leave this part empty as well and do the incrementation in the inside of the for loop. Because we can do this because our I++ was getting called after each operation, each execution of the for loop. For example, this print function gets called, and after that, after getting out of this for loop and going back to beginning of this for loop, I++ gets called, and for example, I gets from 0 to 1. So we can do this in here, and we'll get same result as well. As you can see, yes, hello world gets printed 6 times as well. So how can we change the condition part? For example, constraint part, I smaller than the 6. For example, we can do that. Let's change that t integer I equals 0. Let's set our check to true and put our check to here and do this in this previous way, and check the condition if check, or no, yes, we're incrementing the I till the 6. So if we can do it like this, if I not smaller than the 6, we can set our check condition to false. Then check condition gets false, and after checking for the next operation, next execution of for loop, we can't get into the false for loop. For example, let's check that out. So compile that and run that. For example, it gets 7 times, I guess, if I don't see it wrong. So it gets with 0 first in the first operation, check is true, and it gets into the for loop with I is equals to 0, I equals to 0, prints hello world, and after that it's smaller than the 6, so check is still true, and after that I becomes 1 and check is true, I becomes 2, check is true, I becomes 3, check is true, and I becomes 4, check is true, and I become 5 and check is true, and gets into the check again. So we have done something wrong. We have to check if I smaller than the 5, so that it becomes here in the last operation. So we basically doing one more execution than the original one. So let's check that out. Yes, now we're printing 6 times hello world. So we have another loop type. By the way, loops are especially really extremely useful in the arrays, and we're going to get to the arrays in the further videos, like initializing arrays or accessing to the index, certain index of elements in arrays, such things like that. For example, we have while loop, and in while loop we set one condition in the parentheses of while loop. For example, I smaller than a 6 again, and we wanna print the hello world. hello world again. But we should define our counter. Let's call it counter. It's called 0 and out of the while loop. So we can call the counter anywhere we want after the for loop. Sorry, while loop. After the while loop. After the while loop, we can call it like this, and it doesn't give us an error. And by the way, we should do the incrementation as we did in for loop. Let's compile this and run. So you're seeing that hello world gets printed 6 times, and after the each operation, for example, counter gets in 0, 1, 2, 3, 4, 5, and after 5th operation, counter is 5, but the execution of the for loop is 6th, because we are getting into the first execution, which was when the counter was 0. So it gets into the here 5th times, and after 5th times counter gets incremented one more time as well, and after that we break from the while loop, and after that see out the counter, then it prints out as 6. So yes, that was the while loop. And there we can, what if we don't increment our counter, let's say, then obviously we're going to have an infinite loop, because counter always is smaller than the 6. We don't increment the counter, so it gets for infinity. And other than that, we have a do while loop, do, and we write the condition to end of the brackets like this. For example, let's use the same continuation again, like this, counter smaller than 6. So we can print high this time, and after each operation, counter, let's increment counter by 1. So the main difference of do while loop, other than the while loop, is in while loop, if counter is not smaller than the 6, it doesn't get into the while loop, never. But in the do while loop, for example, let's say counter is 0, but let's make the counter is 6. So if we define implement and counter and use the same statement high, we won't get into the high because counter is not smaller than a 6. But in the do while operation, we print high, we do the body of the do while loop first time, and after increment to counter, and after check the condition. For example, in here we don't have to increment the counter as well. So let's check this. Let's clear that. So compile that. Run that. So as you can see, we don't, so to recognize, to understand which one, to see which high is that, we can put here an second while statement in here to understand which while loop it's executed. So yes, and so it skips the first while because counter is 6, and after that it prints the do while. It gets into the do while without looking to checking our condition. It prints high, and after that it checks our condition counter not smaller than 6. It's equal to 6, so it never gets into the do while loop again. So our loops, as I said, these loops are extremely useful on arrays when we trying to access the arrays by index, and we are going to explain the arrays in further videos to you. So that's it for this video. Thanks you for watching, and have a nice day.